Let's begin our journey by understanding what an electromagnet actually is. Unlike a regular magnet, which is always magnetic, an electromagnet is a special type of magnet that only works when electricity flows through it. This means you can turn its magnetic power on or off with the flip of a switch. Electromagnets are made by winding a wire into a coil, usually around a piece of iron or another metal. When electric current passes through the coil, it creates a magnetic field, turning the core into a magnet. This simple yet powerful concept is the foundation for many modern technologies. Story of electromagnets begins in the early 19th century, when scientists first discovered the connection between electricity and magnetism. Hans Christian Ørsted, a Danish physicist, noticed that a compass needle moved when placed near a wire carrying electric current. This groundbreaking observation revealed that electricity could create a magnetic field. Soon after, other scientists like André-Marie Ampère and Michael Faraday expanded on this idea, leading to the invention of the first electromagnets. Their discoveries paved the way for countless innovations that shape our world today. Oh, how does an electromagnet actually work? The secret lies in the flow of electric current through a coil of wire. When you connect the coil to a battery or power source, electrons start moving through the wire. This movement generates a magnetic field around the coil. If you place a piece of iron inside the coil, the magnetic field becomes much stronger, turning the iron into a powerful magnet. When you turn off the electricity, the magnetic field disappears, and the iron loses its magnetism. This ability to control magnetism with electricity is what makes electromagnets so useful. Electromagnet is made up of a few simple parts. First, there's the coil of wire, usually made from copper because it's a great conductor of electricity. Next, there's the core, often a piece of iron, which sits inside the coil. The core helps to concentrate and strengthen the magnetic field. Finally, you need a power source like a battery to provide the electric current. When all these parts come together, you have a device that can create a strong, controllable magnetic force with just the flip of a switch. One of the coolest things about electromagnets is that you can turn their magnetic power on and off. When you switch on the electric current, the electromagnet becomes active and can attract metal objects. When you switch off the current, the magnetism disappears instantly. This feature is incredibly useful in many applications, from industrial machines to everyday gadgets. It's like having a magnet with a built-in on-off switch, giving you precise control over when and how it works. You might wonder, why not just use regular magnets? The answer is control. Electromagnets allow us to turn magnetism on and off, adjust its strength, and even reverse its direction. This flexibility makes them perfect for tasks where permanent magnets would be too limiting. For example, in electric motors, cranes, and medical devices, being able to control the magnetic field is essential. Electromagnets give us the power to harness magnetism in ways that permanent magnets simply can't match. Electromagnets are all around us, even if we don't always notice them. They're inside the speakers that play our music, the MRI machines that help doctors see inside our bodies, and the electric bells that ring in schools. They're also used in junkyard cranes to lift heavy metal objects, and in trains that float above the tracks using magnetic levitation. Every time you use a device that relies on electricity and magnetism working together, there's a good chance an electromagnet is involved. Factories and industrial settings, electromagnets play a crucial role. They're used in machines that sort and move metal parts in conveyor belts and in powerful lifting cranes. These cranes can pick up and drop heavy steel beams with ease, simply by turning the electromagnet on or off. This makes construction and recycling much more efficient and safe. Electromagnets are also used in manufacturing processes such as welding and assembly lines, where precise control is needed. Transportation has been revolutionized by electromagnets. Maglev trains, for example, use powerful electromagnets to float above the tracks, reducing friction and allowing for incredibly fast and smooth rides. Electromagnets are also found in electric cars, where they help control motors and braking systems. Even in airplanes, electromagnets are used in various control and safety systems. Their ability to provide strong, controllable forces makes them ideal for modern transportation technologies. The medical field, electromagnets are nothing short of lifesavers. MRI machines use strong electromagnets to create detailed images of the inside of the human body, helping doctors diagnose and treat illnesses. Electromagnets are also used in devices that help control heartbeats, such as pacemakers, and in surgical tools that require precise movements. Their ability to generate powerful, controlled magnetic fields makes them essential in modern healthcare. Communication devices like telephones, microphones, and speakers rely on electromagnets to convert electrical signals into sound and vice versa. In a speaker, for example, an electromagnet moves a diaphragm back and forth, creating sound waves that we can hear. This technology is at the heart of everything from smartphones to large concert speakers, making clear communication possible across the globe. Security systems often use electromagnets in locks and alarms. Electromagnetic locks, or maglocks, are commonly found on doors in offices and secure buildings. When electricity flows through the lock, it creates a strong magnetic force that keeps the door securely closed. If the power is cut, the lock releases, allowing the door to open. This provides both security and safety in emergency situations. Even the world of entertainment benefits from electromagnets. In amusement parks, electromagnets power roller coasters and rides, providing smooth acceleration and braking. In theaters and cinemas, speakers and sound systems use electromagnets to deliver immersive audio experiences. Video game controllers and pinball machines also use electromagnets to create interactive effects, making entertainment more exciting and engaging. Scientific research, electromagnets are essential tools. Particle accelerators, which study the smallest building blocks of matter, use powerful electromagnets to steer and focus beams of particles. Laboratories use electromagnets in experiments that require strong, adjustable magnetic fields. Their precision and strength make them invaluable for pushing the boundaries of scientific knowledge. Recycling centers use large electromagnets to separate and move metal objects. These magnets can pick up heavy scrap metal and drop it into the right bins with just the flip of a switch. This makes sorting and recycling metals much faster and more efficient, helping to conserve resources and protect the environment. On construction sites, electromagnets are used in cranes and lifting equipment to move heavy steel beams and other metal materials. By turning the electromagnet on, workers can pick up large objects safely and easily. When the job is done, turning off the magnet releases the load. This technology improves safety and efficiency in building projects of all sizes. In classrooms and science labs, electromagnets are used to teach students about electricity and magnetism. Simple experiments with coils, batteries, and iron nails help students see how electromagnets work. These hands-on activities make learning about science fun and interactive, inspiring the next generation of inventors and engineers. Many household appliances use electromagnets to perform everyday tasks. Washing machines, for example, use electromagnets to control the locking and unlocking of doors. Doorbells, electric fans, and even some kitchen gadgets rely on electromagnets to function smoothly. These hidden helpers make our daily lives more convenient and efficient. Robots often use electromagnets to pick up, move, or sort metal objects. In factories, robotic arms equipped with electromagnets can handle parts with precision and speed. This technology allows robots to perform tasks that would be difficult or dangerous for humans, making manufacturing safer and more efficient. Some toys use electromagnets to create fun and interactive experiences. For example, magnetic building sets and train tracks use electromagnets to connect pieces or move trains. These toys not only entertain but also teach children about the principles of magnetism and electricity in a playful way. Artists and designers sometimes use electromagnets to create moving sculptures or interactive installations. By controlling the magnetic fields, they can make parts of their artwork move, float, or respond to viewers. This blend of science and creativity opens up new possibilities for artistic expression. Space exploration relies on electromagnets in many ways. Satellites use electromagnets to adjust their orientation in space, while spacecraft use them in docking systems and scientific instruments. Electromagnets help ensure that missions are successful and that equipment works reliably in the harsh conditions of outer space. Researchers use electromagnets in a wide range of experiments, from studying the properties of materials to exploring new forms of energy. Their ability to create strong, adjustable magnetic fields makes them ideal for testing theories and developing new technologies. Electromagnets are at the heart of many scientific breakthroughs. Even in agriculture, electromagnets play a role. Some modern farming equipment uses electromagnets to sort seeds, control machinery, or operate automated systems. This technology helps farmers work more efficiently and produce better crops, showing that electromagnets have a place in every corner of our lives. Banking and finance systems use electromagnets in devices like card readers and ATMs. Electromagnetic sensors help read the magnetic strips on credit and debit cards, allowing for secure transactions. This technology keeps our financial information safe and makes everyday banking quick and convenient. Musical instruments and audio equipment often use electromagnets. Electric guitars, for example, use electromagnetic pickups to convert string vibrations into electrical signals, which are then amplified into sound. Speakers and headphones also rely on electromagnets to produce clear, powerful audio, bringing music to life. Power plants use electromagnets in generators to produce electricity. When a coil of wire spins inside a magnetic field, it generates electric current. This process, called electromagnetic induction, is the backbone of modern electricity generation, powering homes, businesses, and entire cities. Some lighting systems, such as fluorescent lamps, use electromagnets to help start and control the flow of electricity. This ensures that the lights turn on quickly and operate efficiently. Electromagnets help make our homes and workplaces brighter and more energy efficient. Many modern clocks and watches use electromagnets to keep time accurately. Electromagnetic coils help move the hands of the clock or control digital displays. This technology ensures that we can always keep track of time, whether at home, at work, or on the go. Navigation systems, such as compasses and GPS devices, sometimes use electromagnets to enhance accuracy. Electromagnetic sensors can detect changes in the Earth's magnetic field, helping guide ships, planes, and even smartphones to their destinations. In research labs, scientists use electromagnets to study everything from the behavior of atoms to the properties of new materials. Their ability to create strong, adjustable magnetic fields makes them perfect for experiments that require precision and control. Automation systems in factories and warehouses often use electromagnets to move, sort, or hold objects in place. This technology allows machines to work quickly and accurately, reducing the need for manual labor and increasing productivity. Packaging machines use electromagnets to seal, move, or sort packages. This ensures that products are packed quickly and securely, ready for shipping to stores or customers. Electromagnets help keep the supply chain running smoothly. Office equipment like printers, copiers, and shredders often use electromagnets to control moving parts. This technology helps these machines operate smoothly and reliably, making office work more efficient and less stressful. Safety systems in buildings and vehicles use electromagnets in alarms, emergency doors, and fire suppression equipment. These systems rely on the quick response and reliability of electromagnets to keep people safe in emergencies. Sports equipment and facilities sometimes use electromagnets for timing systems, scoreboards, and even training devices. Their precision and reliability help athletes and coaches track performance and improve results. In the food industry, electromagnets are used in packaging machines, sorting equipment, and even in some cooking appliances. They help ensure that food is processed, packed, and delivered safely and efficiently to consumers. Environmental protection efforts use electromagnets to clean up pollution, sort recyclable materials, and monitor environmental conditions. Their ability to move and separate metals makes them valuable tools in keeping our planet clean and healthy. The military uses electromagnets in a variety of equipment, from communication devices to advanced weapon systems. Electromagnetic launchers, for example, can fire projectiles at high speeds using magnetic forces, offering new possibilities for defense technology. During disasters, electromagnets can be used in search and rescue equipment to move debris or operate remote-controlled tools. Their strength and reliability help emergency teams save lives and respond quickly to dangerous situations. Fashion designers have started experimenting with electromagnets to create clothing and accessories that can change shape or color. By applying a magnetic field, these items can transform in real time, offering new ways to express personal style. Research vessels exploring the ocean use electromagnets in their equipment to collect samples, operate underwater vehicles, and study marine life. Their ability to work reliably in challenging environments makes them essential for ocean exploration. Smartphones, tablets, and other smart devices use tiny electromagnets in their speakers, vibration motors, and sensors. These components help deliver clear sound, haptic feedback, and accurate measurements, making our devices more responsive and enjoyable to use. Research satellites use electromagnets to control orientation, stabilize instruments, and perform scientific measurements in space. Their reliability and precision are crucial for gathering accurate data and supporting space missions. As technology advances, electromagnets will continue to play a vital role in shaping our world. From quantum computers to advanced transportation and medical breakthroughs, the possibilities are endless. By harnessing the power of electromagnetism, we can unlock new frontiers in science, industry, and everyday life. The journey of electromagnets is far from over, and their impact will only grow in the years to come.